Hello students, today I am going to discuss variable acceleration related kinematics problems and how to solve the problems based on that one we will discuss today. Okay, so first, already in the previous classes maybe you learned kinematic equations are applicable only for the bodies which are moving with the uniform acceleration. And by considering the mass body as a point mass, we are applying the kinetic equations, and you know that kinetic equations are okay, v is equal to u plus at, one equation, v square minus u square is equal to 2s, second equation, s equal to ut plus half at square is the third equation, and sn is equal to un plus a by 2 into 2n minus 1 is the fourth equation. These are the four kinetic equations we are already learned in the previous classes. In that, this is the A called acceleration. Every case the acceleration is uniform. Okay, in the case of NEET examinations up to the uniform acceleration, they can go for the problems. In the case of mains examination, G-mains or advanced examination, they will go for non-uniform accelerated also. So in the case of non-uniform acceleration, means where the velocity changes time to time, in that cases we are solving the problems using integration and differentiation method, right? So before solving that, you have to be practice of formulas of differential equations and integration equations formulas you have to modify. So directly we are going to how to solve the problems here based on that discussion here. So example problems I will take and we are going to discuss here. Now first model, a particle. Consider a particle of negligible mass, okay, which is moving in the space. The motion of this particle, that is means the displacement of the particle is given as x equal to 4t square plus t. This is the equation is given. Now what are the questions they can ask? Using a single equation they can ask the many questions. That is, first one, what is the initial displacement of the particle? Second question, what is the initial velocity of the particle? What is the initial velocity of the particle? And the third one, what is the initial acceleration of the particle? These are the three questions they are going to ask. So I'm going to take 0 here. So what is initial displacement? What is initial velocity? What is initial acceleration of the particle? So first, before solving that, first you have to understand the equation which is given. Look at this equation. What is given in the equation? X is called displacement. The displacement is a variable function, okay, that is given in terms of 4t square plus t, where t is also a variable. As time changes, x value also changes. So both are variables. So according to that one, to solve this one, first they are asking initial displacement. Initial means what? Starting. Whenever the condition is given initial, always the time we have to take it as 0. That means the displacement initially at time t equals 0 called as x naught, because time t equals 0 if you apply x naught is equal, put the t value 0, that is 4 into 0 square into 0 plus 0. How much you are going to get? That is 0. So initially the particle is at rest condition 0, having displacement 0 initially. Now what is the second question? The second question is initial velocity. What is initial velocity? Initial velocity means at starting time. At time t equal to 0, what is the velocity of this one? That means v naught is equal to how much? So if you want to calculate the v naught is equal to how much? V naught is equal to, take the first to get the v naught. You know that if v is called nothing but velocity. Velocity nothing but according to basic rate of change of displacement. So I can write this one in terms of differential function as dx by dt. So this is, I can write as v naught is equal to d by dt is a function. You know that x is called displacement. Here x displacement formula is given. So equation is given how much? Not formula. Equation is given 4t square plus t is given. So while solving, what you have to do, basically this differential function you apply for both the terms separately. That is d by dt of 4t square first term plus second term is d by dt of t. This way you have to apply. Now after applying, just now solve it using differential formulas. So 4 is constant, no differential function. So d by dt of this I can write as t square, and plus this is dt by dt you will get. So after solving this one, what we are going to get? Initial velocity at time t equals 0 is equal to 4 into differentiation of t square. This is in the form of okay d by okay dx of x power n formula, where it is in the form of this n into x power n minus 1 is the formula for this, n into x power n minus 1. So the same form it is, that's why what I can write, this is t square if you taken, that is equal to 2t I can write. Directly I am writing here 2t. Otherwise if you are having doubt, in the place of x I have t, in the place of n I have a 2, so 2 into t power x plus t, 2 minus 1, 2 minus 1 how much? 1. So this is plus dt by dt nothing but 1, because differentiation of same function you will get 1.